Hi, good morning to all. This is a EDA tool exploration series. So, in that we can see tools from the Cadence and the Synopsys. At the beginning, we just check the test code as well as VCS Compile and Simulation from the Synopsys. So, for the test code, we take the sequential circuits. So in that most familiar circuit is like a sequence detector. So there are two types of sequential detector is that Moore and Mealy. So for that have the block diagram. This is for the Moore machines and this is for the Mealy machine. Generally the difference only is that in Moore the output depends on the current state, and in Mealy output depends on the current state as well as the current present input. So there are other very deep differences are there for number of states are required like that, and glitches happens in that. So we are not going into much detail of that. We just check as a test code. For the VCS you can take any code like Verilog, VHDL or any gate level netlist as well. So for that we already have the code with us. We just overlook that only so that we can go for the simulation purpose or compilation purpose. So this is a simple Moore FSM which detects the 1101. Inputs are there, state encoding values are there. This is reset state. These are the patterns detection states 1101 like that. So registers, current state register, next state registers, sequential block for the reset purpose, and the next state logic. So this is combinational design which defines the which next state will be there on the basis of the D in logic. This is a combination block for the output. It specifically mentioned that it depends on the current state. So whatever the current state has a state like in this case it is a S4, the output will be logic 1. In else condition it will be 0. So back to the console. In VCS actually what happened, we have to use either a command prompt as well as GUI. In command actually VCS is a command. We have to specify the flags of the VCS. You can refer the user guide for that, and then file list -f file list. File list has all the paths that going to be compile or simulate. So and the also we have to mention the top and the log file like that. So in the command prompt we can go in that way, or you can use the tickle files or make files. So I just create one make file which collaboratively take the inputs what we required, like which is a simulation executable, which is a command for VCS like that, and the flags, everything is listed on that make file. You just overview that. As I said, this is compile VCS command, sim command, then file list. All files.txt has a list of paths where the modules are present and that going to be compile and simulate. These are VCS flags. Okay, you can refer the details PDF for that from the VCS user guide. Log files, you have to mention either here directly the top module name, or you can use the command prompt like make top equals to, like that. As I told that this is simple command. This is a VCS flags file list top and the log file. So you can pause and you can refer this all these things. Okay. For now from this, as I told you, the command is like that, make top equals to name of the top level module. Here we have the test bench. If I not go to that file, at the bottom there is a, I written the test bench for this sequential detector. Is some resistors, wires, instances, clock generation. I make a task for the this simulation that has three inputs actually. Data input 8-bit, expected data out 8-bit, the length, how much bits we have to check. There is a for loop for the length, and one by one data bits taken from the data in placed to the data D in, and check for the data out if it is equal or not to the expected one. So it will flash the message like false, pass, at what time, what data input, what data output is there, what we are expecting. So all these are the text messages we get in the console. Obviously there is a initial block and the end block. We have the task name, input, data, expected output, number of bits, test case 1, test case 2, test case 3. So these are the way we have to write the test benches. So again we go back to this. So the command is very simple, make top equal to whatever the top level module we have, just enter it. If that has any error or something like that, you can refer the log file, or you can check the command window messages there. Okay, like this one. So the code is already tested, so I don't think it is anything have like errors. So after this there will the window will comes like dv name top level 1, source is given. So this is our test bench with a device under test is our sequential detector. You can either select one by one, or you can either control A. Also we can check the schematic, right click here, you can go to the schematic. As we discussed, this is our next state at current state logic, output logic, and the input depends on the input, it will be going to the next state logic actually. So for the simulation purpose, you just select all the required signals, and either you have to right click, add to waveform, or you can have the control 4. So I go select all, control 4, it will pop up another window, and from that you can just simulate or hit F5. So I just hit F5. Okay, let it. So from that we get the waveforms. So input clock, we place the clock and D in between, so that we can two logic 1 0, another one, that is sequence 1 1 0 1, so output is 1. Same cases happen here. So this is just an overview of the how we can write a code or write a make files, how we place compilation and the simulation using VCS. This is just introduction. Later on we see in more detail. Hope you find this video useful, please subscribe my channel. Thank you.